Good morning. Today's topic is transformer equivalent circuit of three-phase induction motor. Induction motor, basically it has three words: three-phase, induction and motor. Three-phase means rotating magnetic field. Induction means the EMF is generated by the induction, and motor means that EMF get converted into current, and that current is converted into the torque. If I talk about transformer equivalent circuit, three-phase induction motor basically is a transformer but with a rotating secondary. If I talk about this model, you can see all the elements are equal or rather same as that of transformer. If I talk about primary, this is a per phase model. I hope three phase, and we are talking about per phase. That means everything, the power get tripled if at the end of the topic. Now, if I talk about this model, if you can see this R1, X1, RE, XM, these all are of the primary, or rather say, I must say this is of the stator elements. R1 means winding resistance, X1 means equivalent magnetic leakage, RE is core losses, and XM is magnetizing component of current. This is similar to a primary of transformer. But I talk about this. If I talk about this, there is something which is new, that is R2 by S into 1 minus S. Now if we have to concentrate on the secondary, that is on the rotor side of the three-phase induction motor. Now at standstill, if I say at stand still. Now, at standstill, if I talk, E2 is equals to I2 is equals to E2 upon Z2, where Z2 is rotor impedance. And E2 is rotor EMF. Both these two components basically are at stand still, means S is equals to 1. Sorry, S is equals to 1. When NR is 0, your S is NS minus NR upon NS. That will be equal to NS minus 0 upon NS, and that is equals to 1. In this case, the I2 is equals to E2 upon under the root R2 square plus X2 square, where X2 is 2 pi FL. In case of standstill, F dash L, F dash is equals to SF, S is equals to 1, so F dash is equals to F. So this is a case of standstill. Now in case I talk about when the motor is running, when the motor runs, S develops a value which is less than 1, that is NR starting to develop, which means this factor of relativity, this factor decreases. Under running conditions, now I2 dash is equals to E2 dash and Z2 dash, where E2 dash is equals to S into E2 and Z2 dash is equals to under the root R2 square plus X2 dash square. Now why X2 dash? Because basically X2 dash is dependent on frequency, this parameter. Now this parameter is basically under running condition is equals to F dash is equals to SF, and when it is equals to SF, X2 dash becomes equal to 2 pi SFL. Now SFL, if I take S common, this is 2 pi FL, and this is equals to a previous X2. So x2 dash is now S into x2, which means the new equation becomes I2 dash is equals to S into I2 under the root R2 square plus S into x2 square. Till now, it is a simple working. Now comes the equivalent model, which will be equal to this. How it will be equal? Let's see this. Finally, I have this equation. I2 dash is equals to S into E2 S into E2 divided by R2 square plus S into X2 whole square under the root. Now if I take S common, I2 dash is equals to E2 upon R2 by S plus X2 square. Further, if I can see this as an impedance, this is Z2 dash will have some real and imaginary part can be written as R2 by S plus JX2 in rectangular form. If I want to draw the equivalent circuit of this particular equation and this EMF, I'll be drawing like this. E2 with the impedance R2 by S plus JX2, and this current is I2 dash. Now it is interesting to note, if I see this model and if I compare this model with the Z2 that is under standstill, it is equals to R2 plus X2 square. The difference you can see by S. Now if I somehow nullify this difference, I can go to that rotor which is not running, which is at standstill. For that, I will be rewriting this equation as Z2 dash is equals to R2 by S minus R2 plus JX2. That is R2 plus R2 by S minus R2 plus JX2. So it can be redrawn as R2 by S minus R2 JX2 E2. This is R2 by S into 1 minus S. Now this resistance is called fictitious resistance. And this circuit is called equivalent circuit of secondary of three-phase induction motor. Now fictitious resistance, what does it mean? Fictitious means which is not real, which doesn't exist. But yes, it comes into the picture as the motor start rotating. In that case, if the motor start rotating, the fictitious resistance comes into picture, then I can see two values of S equals to 0, S equals to 1. This fictitious resistance become, let's say this is equals to RF. RF becomes, when S equals to 0, it is infinite, and when S equals to 1, it becomes 0. This is when NS and NR are equal. Hence RF becomes infinite, NS and NR are equal, so I2 will be 0 and no further torque, no further current, no further current I2 dash will be there in the circuit, and due to which torque becomes 0. If I see second condition, when RF is 0, that means when NR is equals to 0, you can see I2 exists, and I2 is equals to E2 upon under the root R2 square plus X2 square, and further this I2 is equals to E2 upon R2 square plus X2 square. Your torque comes into the picture. So in this case you have torque, in this case the torque becomes 0, the value of S is from 0 to 1, and finally we can see the rotor can run in the speed from 0 to NR and from this number of torques. This is the rotor equivalent circuit of three-phase induction motor. Three-phase induction motor, secondary side bit different from transformer, primary side is exactly same with the transformer. Thank you.